Welcome all of you to the chemistry online classes. Today we want to discuss about the two more important effects. In last class we have discussed already about the inductive effect and the types of the inductive effect. In today's class we want to discuss two more important effects. In that, first we will start with the electromeric effect. So what is electromeric effect? So what are the types and how exactly it will going to occur, that we are going to discuss. So first of all we will go for the statement or what is the definition of the electromeric effect, that we will discuss. See here, electromeric effect is the complete transfer. It means there is a complete transfer or shift. What it will going to shift, or there is a complete transfer of what happens? There is a complete transfer or shift of the pi electron pair of a multiple bond to one of the bonded atom, where it is the complete transfer or complete shift of the pi electron of a multiple bond system to the one of the bonded atom during the attack of positively or negatively charged reagent. Suppose you consider this is the multiple bond system. Multiple bond, maybe that I will explain you here. Multiple bond system, double or triple, like that bond system. Okay, that bond system is there, means during that time the complete transfer of the pi electron pair of this multiple bond to one of the bonded atom. So suppose if you consider this is the bonded atom and this is the multiple bond system. So what is the definition? The complete shift of the pi electrons of this multiple bond to the bonded atom when it occurs in presence of any one of the positively or negatively charged attacking reagent. Okay, ಯಾವುದೇ ಒಂದು ಮಲ್ಟಿಪಲ್ ಬಾಂಡ್ ಸಿಸ್ಟಮ್ದಿಂದ ಪೈ ಎಲೆಕ್ಟ್ರಾನ್ ಪೇರ್ ಏನಾಗತೈತಿ, ಕಂಪ್ಲೀಟ್ ಆಗಿ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗತೈತಿ. ಯಾರಿಗೆ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗತೈತಿ? ಸೊ ಇಲ್ಲಿ ನೋಡ್ರಿ, ಒನ್ ಆಫ್ ದಿ ಬಾಂಡೆಡ್ ಆಟಮ್, ಅದರ ಜೊತೆ ಬಾಂಡ್ ಇರುವಂತ ಆಟಮ್ ಜೊತೆ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗಕತ್ತೈತಿ. ಆ್ಯಂಡ್ ಯಾವಾಗ ಆಗ್ತೈತಿ ಅದು ಇಂಪಾರ್ಟೆಂಟ್, ಡ್ಯೂರಿಂಗ್ ದ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ದಿ ಅಟ್ಯಾಕಿಂಗ್ ರಿಯೇಜೆಂಟ್. ದಟ್ ಅಟ್ಯಾಕಿಂಗ್ ರಿಯೇಜೆಂಟ್ may be positive or it may be a negative. Okay, so what is electromeric effect? It is shortly written as E effect. It is also shortly written as E effect ant helinu karitivi. So what is the definition of the electromeric effect? The complete transfer of the pi electrons of the multiple bond to one of the bonded atoms during the presence of the positively or negatively charged attacking reagent. Clear? I hope so. The definition is clear. Simple. ಒಂದು ಮಲ್ಟಿಪಲ್ ಬಾಂಡ್ ಸಿಸ್ಟಮ್ ಇರ್ತೈತಿ, ಆ ಮಲ್ಟಿಪಲ್ ಬಾಂಡ್ ಸಿಸ್ಟಮ್ನಿಂದ ಪೈ ಎಲೆಕ್ಟ್ರಾನ್ ಪೇರ್ ಏನಾಗ್ತಾವ್ರಿ, ಕಂಪ್ಲೀಟ್ ಆಗಿ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತಾವು. ಯಾರಿಗೆ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತಾವು? ಬಾಂಡೆಡ್ ಆಟಮ್ಗೆ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತಾವು ಇನ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ದಿ attacking reagent. That attacking reagent may be positively charged or it may be a negatively charged one. Clear? So next, in presence of the attacking reagent, it takes place. If the reagent is removed, the molecule reverts back to the original. What it means? The electromeric effect is possible in presence of the attacking reagent. Suppose if I remove the attacking reagent, again the molecule comes to the previous placement or previous original shape or original arrangement of the molecules it will going to attain. So the reaction or this effect is shown in presence of the attacking reagent. Suppose if I removed the attacking reagent, again the similar positions of the group is attained here. And the third point is depending upon the direction of the displacement of the pi electrons, because pi electron pair is transferring, depending upon its displacement, the electromeric effect is divided into two categories. The electromeric effect is divided into two categories on the basis of the transfer of the pi electron pair. Clear? So first one is minus E effect. So what is the minus E effect? See here I said you compulsory there must be an attacking reagent. Okay, suppose an attacking reagent, just you look at this example, suppose this is the attacking reagent, when the attacking reagent approaches this system, so the pi electrons of the multiple bond, the pi electrons of the multiple bond are shifting to the bonded atom, one of the bonded atom, where exactly it is taking? So it is away from the attacking reagent. So ಇಲ್ಲಿ ನೋಡ್ರಿ CN ಈ ಕಾರ್ಬನ್ ಮೇಲೆ ಏನಾಗಕತ್ತೈತ್ರಿ ಅಟ್ಯಾಕ್ ಆಗಕತ್ತೈತಿ. ಸೊ ಅವಾಗ ಈ ಬಾಂಡ್ ಎಲ್ಲಿ ಶಿಫ್ಟ್ ಆಗಕತ್ತೈತಪ್ಪ ಆಕ್ಸಿಜನ್ ಮೇಲೆ ಶಿಫ್ಟ್ ಆಗಕತ್ತೈತಿ. ಓಕೆ, ಹಾಗಂದ್ರೆ ಈ ಶಿಫ್ಟ್ ಅವೇ ಫ್ರಮ್ ದಿ ಈ ಅಟ್ಯಾಕಿಂಗ್ ರಿಯಜೆಂಟ್ದಿಂದ ದೂರ ಆಗತೈತಿಲ್ರಿ, ಏನು ಅದಕ್ಕೆ ಅದ್ರ ಕಡೆನೇ ಆಗಕತ್ತೈತೋ ಇಲ್ಲ, ಅದರಿಂದ ಏನಾಗತೈತಿ ದೂರ ಆಗತೈತಿ. ಇಂಥ ಇಫೆಕ್ಟಿಗೆ ನಾವು ಏನಂತ ಕರಿತೀವಪ್ಪ ಅಂದ್ರೆ ಮೈನಸ್ ಇ ಇಫೆಕ್ಟ್ ಅಂತೇಳಿ ಕರಿತೀವಿ. ಕ್ಲಿಯರ್? ಅದನ್ನೇ ಸ್ವಲ್ಪ ನೀಟಾಗಿ ಡೆಫಿನೇಷನ್ ಒಳಗೆ ಬರೆದ್ರೆ ಏನಾಗೈತಿ ನೋಡ್ರಿ, ಆ್ಯನ್ ಅಟ್ಯಾಕಿಂಗ್ ರಿಯಜೆಂಟ್ ದಿಸ್ ಇಸ್ okay, an attacking reagent is said to have the minus E effect. ಇದು minus E effect ತೋರ್ಸಾಕತ್ತೈತಿ ಅಂತ ಯಾವಾಗ ಹೇಳ್ತೀವಪ್ಪ ಅಂದ್ರೆ when the direction of the pi electron pair transfer, when the direction of the pi electron pair transfer of the multiple bond is away from the attacking reagent. ಈ attacking reagent ಇಲ್ಲಿ ಬರಾಕತ್ತೈತಿ ಅಂದ್ರೆ ಇದು ದೂರ ಹೊಂಟೈತಿ, ಶಿಫ್ಟ್ ಏನಾಗಕತ್ತೈತ್ರಿ ಮಲ್ಟಿಪಲ್ ಬಾಂಡ್ ಸಿಸ್ಟಮ್ ದಿಂದ ಅವೇ ಆಗಕತ್ತೈತಿ. ಈ ರೀತಿ ಇಫೆಕ್ಟ್ ಇತ್ತಪ್ಪ ಅಂದ್ರೆ ಮೈನಸ್ ಇ ಇಫೆಕ್ಟ್ ಅಂತೇಳಿ ಕರಿತೀವಿ. ಅರ್ಥ ಆಗತೈತಿ? ಇದು ಒಂದು ಮಲ್ಟಿಪಲ್ ಬಾಂಡ್ ಸಿಸ್ಟಮ್ ರೀ. ಈ ಮಲ್ಟಿಪಲ್ ಬಾಂಡ್ನಿಂದ ಪೈ ಎಲೆಕ್ಟ್ರಾನ್ ಪೇರ್ ಏನಾಗಕತ್ತವ್ರಿ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗಕತ್ತವು. ಎದರಿಂದ ಅಟ್ಯಾಕಿಂಗ್ ರಿಯಜೆಂಟ್ದಿಂದ ದೂರ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗಕತ್ತವ, ಅವೇ ಫ್ರಮ್ ದ ಅಟ್ಯಾಕಿಂಗ್ ರಿಯಜೆಂಟ್. ಸಚ್ ಅ ಟೈಪ್ ಆಫ್ ದಿ ಇಫೆಕ್ಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಮೈನಸ್ ಇ ಇಫೆಕ್ಟ್. ಕ್ಲಿಯರ್? So what is the definition? An attacking reagent is said to have minus E effect when the direction of the pi electron pair, of the multiple bond is away from the attacking reagent. So ಇಲ್ಲಿ ನೋಡ್ರಿ ಅಸಿಟಾಲ್ಡಿಹೈಡ್ ಐತಿ, ಕಾರ್ಬನ್ ಗೆ ಒಂದು ಗ್ರೂಪ್ CH3, ಒಂದು ಹೈಡ್ರೋಜನ್ and double bonded oxygen. When CN attacks on it, this bond gets transferred here and CN gets detached here, and here the pi bond is shifted to the oxygen which is away from this attacking reagent. So this is how we can explain about the minus E effect. Clear? I hope so it is clear. So next, plus E effect. Can you guess it? Can you guess it? Exactly. Minus E effect is there, plus E effect is reverse of it. What happens? The transfer of the pi electron pair of the multiple system to the bonded atom, that is towards the attacking reagent. That takes place towards the attacking reagent. See here, and that I will explain you through the example. So this is the example. This is the example for the plus E effect here. So plus E effect example we are telling means here this is the attacking reagent. So this is the attacking reagent. Here the attacking reagent is positively charged. Here the attacking reagent is positively charged. When it approaches this, the multiple, that is the pi electron pair of the multiple bond system will going to be shift towards the attacking reagent. Shift towards the attacking reagent. Here it is towards the attacking reagent. Just you observe these two. See here propene is the product and this is the attacking reagent to the carbon, and here it is also transferred, that is the pi electron pair of this multiple system is also transferred towards the attacking reagent. So what happens here? CH3, and here this CH, its electron is lost, it got the positive charge, and this become, by taking an electron it become CH2 become CH3. Clear? Simple concept. Electromeric effect is nothing but transfer of the pi electrons of the multiple bond to the bonded atom. in presence of the attacking reagent. The attacking reagent may be positive or negative, and this effect does not show in absence of the attacking reagent. So, if I remove the attacking reagent, again the molecule reverts or it retains the previous placement, clear, and depends upon the direction of the transfer of the pi electron. It is categorized into two categories. One is minus E effect, one more is plus E effect. In case of the minus E effect, the transfer of the pi electrons of the multiple bond is away from the attacking reagent, where in case of the plus E effect, it is towards the reagent. It is, that is, the transfer of the pi electron pair of the multiple bond is towards the what we can say attacking reagent. So, this is how we can explain about the electromeric effect, clear, and this electromeric effect is categorized into two categories, and whether the attacking reagent is positive or negative, it does not matter, but it should be there. If I remove the attacking reagent, then the molecule again regains its original what we can say placement or original arrangement, it will going to be takes place. I hope so it is clear ಆಗೈತೆ ಅಂತ ಹೇಳಿ ನಾನು ಅನ್ಕೋತೀನಿ ರೀ. ಸೊ ಹಂಗಂದ್ರೆ ನೆಕ್ಸ್ಟ್ ಇಫೆಕ್ಟ್ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಸೊ ಇವಾಗ ಯಾವ್ಯಾವ ಇಫೆಕ್ಟ್ ಡಿಸ್ಕಷನ್ ಆದವು ರೀ? ಇಂಡಕ್ಟಿವ್ ಇಫೆಕ್ಟ್, ನೆಕ್ಸ್ಟ್ ಎಲೆಕ್ಟ್ರೋಮೆರಿಕ್ ಇಫೆಕ್ಟ್, ಇಟ್ ಈಸ್ ಆಲ್ಸೋ ಕಾಲ್ಡ್ ಅಸ್ ಇ ಇಫೆಕ್ಟ್ ಶಾರ್ಟ್ಲಿ. And next we will go for the resonance effect. So, you might be heard that resonance, it means the shifting of the bond will going to be takes place in a multiple bond system. For example, here this is the structure of which compound? It is the structure of the benzene. When the pi electrons are shifted from here to here and here to here, means the resonance. These two are the resonating structures of the benzene. That resonating structure, that concept we will discuss. Now we are discussing about effects. That's why I am telling you what is resonance. Resonance is nothing but delocalization of the pi electrons of the system. ಸೊ ಇಲ್ಲಿರುವಂಥ ಪೈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನಾಗತ್ತವ್ರಿ? ಡಿಲೋಕಲೈಸ್, ಒಂದ ಕಡೆ ಇಲ್ಲ, ಅದರ ಪ್ಲೇಸ್ಮೆಂಟ್ ಏನಾಗತ್ತೈತಿ? ಚೇಂಜ್ ಆಗಕತ್ತೈತಿ. ಅದಕ್ಕೆ ನಾವೇನಂತೀವಪ್ಪ? ರಿಸೊನೆನ್ಸ್. ಸೊ ಇವಾಗ ಏನು ಡಿಸ್ಕಸ್ ಮಾಡಕತ್ತೀವಿ? ರಿಸೊನೆನ್ಸ್ ಎಫೆಕ್ಟ್. ಸೊ ನೋಡ್ರಿ, resonance effect is also called as mesomeric effect. It is also called as mesomeric effect. In your examination, sometimes they will directly ask what is resonance effect. Sometimes they will also ask you what is mesomeric effect. So, it is shortly written as either R effect or it is M effect. Either it is R effect or M effect, both are right only. If you call it as a mesomeric effect, you can use M effect. If you call it as a resonance effect, you can use the R effect. Clear? So, let us go for the definition of the resonance effect. So, what is the definition here? The polarity is produced in a molecule by the interaction of the two pi bonds. The polarity, already said you what is polarity, generation of the poles, that is positive and negative pole. Then here the polarity is produced. Then how it is produced, that we will discuss. The polarity is produced in a molecule by, it means how? By the interaction of the two pi bonds, by the interaction of the two pi bonds or between the pi bond and lone pair of the electrons present on the adjacent atom. See here, what is the resonance effect is nothing but here the polarity is generated. Here the polarity is generated in the molecule. How it is generated? Either by the interaction of the two pi bonds or it is the interaction between the pi bond and lone pair of the electrons present on the adjacent atom. So, that is what the resonance effect definition will be there. Clear? When this definition is clear, when I show you an example, suppose if you consider here, For benzene ring, NH2 is attached, that is N is having a lone pair of electron, nitrogen. So these are the lone pair. Whether resonance effect is nothing but whether these pi bonds will going to interact or lone pair of the adjacent atom and this pi bond will going to be interact. So that I will explain you by taking an example clearly. Just to keep in mind that what is the resonance effect. Here the polarity, the effect where the polarity is produced in a molecule by the interaction of the two pi bonds or in between the pi bond and lone pair of the adjacent atom. Clear? So see here, next few points. This resonance effect is transmitted through the entire conjugate system. Throughout the conjugate system, the resonance effect is continued. It will not going to stop at the middle. It will going to be continuously. That is, the effect is transmitted through entire conjugate system. To entire conjugate system, it will going to be carried out. Next, depends upon the direction of the electron pair shift in the conjugate system. So where the electron shift depends upon its direction, whether it will what we can say, it is towards the conjugate system or it is away from the conjugate system, depends upon the direction of the electron pair shift. This R effect is categorized into two categories. Okay, it is divided into two categories. One is plus R effect, that is positive R effect, resonance, positive resonance effect. So what it says, see here the electron pair, what is the electron pair? Either it may be a pi electron or it may be a lone pair of electron. Transfer is away from the substituent attached to the conjugate system. Suppose this is the conjugate system if you consider, and here if it is a substituent. So whatever it is attached, that is the substituent. Suppose what is the plus R effect when it occurs? When the pi electron or lone pair transfer is away from the substituent attached to the conjugate system. This has the capacity to give these electron here, this here, this here, this here. So the transfer is away from this substituent, am I correct? The transfer, this lone pair transfer is away from the substituent NH2, which is attached to this conjugate system, this conjugate system. So that you can able to understand R effect clearly if I took any example that we will discuss here. So first you need to know about the clarity of the definition. What is the resonance effect? The polarity is produced in a molecule. Polarity is produced in a molecule by the interaction of the two pi bonds, or the interaction is in between pi bond and lone pair of the electron present on the adjacent atom. Okay, and effect is transmitted through entire conjugate system. Effect is transmitted through the entire conjugate system, and depending upon the direction of the electron pair movement or interaction, it is categorized into two categories. One is plus R effect, that is how here the lone pair transfer is away from the substituent. So example we will discuss. So let us discuss about the plus R effect example. See here, aniline shows the plus R effect. Okay. So what is the plus R effect? Already we have said the definition, that is electron pair will going to be transfer. That is how it will transfer away from the substituent. Electron pair transfer is away from the substituent. See here, this is the substituent while this is the conjugate system. So here what happens? Aniline, this is the structure of the aniline, and nitrogen carries a lone pair of electron, and this lone pair of electrons are released towards this conjugate system or released towards the ring. Okay. So when this is shifted here, this double bond will going to be shift here. So during that time what happens? Here there is a formation of the double bond, and this bond is shifted here and it is represented by the lone pair of the electron. So in the next resonance what happens? These bonds are again shifted here and these are shifted here. Okay, and here it is like this and here it is like this. And in further one more resonating structure, this will shift here and this will shift here. And here this is shifted here and this is shifted here. Okay, see here, this is the substituent, this is the substituent. Here the lone pair of electrons present on the nitrogen is transferred away from this substituent. Yes or no? It is going away from the substituent. Such a type of the effect is called as plus R effect. The transfer, the electron pair transfer is away from the substituent attached to the conjugate system. So the example is aniline. Then which are the further groups can produce the plus R effects? Here OH, OR, that is OCOR, NH2, all these are the groups which can able to give the plus R effect, and these groups are called as electron releasing groups. It means they can release the electron towards the ring. These are called as electron releasing groups. So ERG means electron releasing groups, and these electron releasing groups can donate their electron towards the ring. It means those electrons are shifting away from that substituent. Such groups can able to give plus R effect. Clear? So let us go for the minus R effect. So it is reverse of it. The transfer is here, the shift of the pi or lone pair of the electron is towards the substituent attached to the conjugate system. Here it is away. It now in this minus R effect, it is towards the substituent. Okay. Let us go for the example nitrobenzene. See here, this is the structure of the nitrobenzene, and here what happens? This bond is shifted here, so that the double bond between the nitrogen and oxygen is shifted here. When this bond is shifted here means here we will get the double bond position, and it lost its electron, means here it will be a positive charge is developed, and oxygen got this pair of this bond, means there is a lone pair of electrons are present. Clear? So next, in the second step what happens? This will going to shift here and it creates the positive charge or positive center here. So the double bond is here and here it is created the positive charge. Further, in another resonating structure, this bond will going to shift here, and in the further structure here it is shifted here while the positive center is created here. And in last position, this double bond will going to shift here as oxygen donates its electron to the nitrogen. Again the nitrogen, in between nitrogen and oxygen, double bond is created, and here it is the bond will going to be, we can able to represent. So here what happens? The shifting of the electron, that is lone pair of the electron, is towards. It is, yes or no? It is towards. It is not away. Away is there here. It is away. But here it is towards this substituent, we can able to say. That's what the minus R effect we can able to explain. Then which type of the groups will going to show the minus R effect, like NO2, CN, RCO, CHO, COH, etc. All these groups are called as electron withdrawing groups. It means they can withdraw the electron from the ring. Such groups can able to show the minus R effect. Clear? So, this is how we can explain about the resonance effect. Resonance effect is also called as mesomeric effect, and I said you the definition is that the polarity is produced here. It means the creation of the poles, that is positive and negative poles, how it is created by interaction of the two pi bonds, or the interaction is in between pi bond and lone pair of the electron present and the which is present on the adjacent atom. And then this effect is transmitted through the entire conjugate system. See here, if you observe these two, entire system it is occurring, and it is categorized into two category. One is plus R effect, one more is minus R effect. In case of the plus R effect, it is the transfer is away from the substituent group, and in case of the minus R effect, it is towards the substituent groups, and the electron releasing groups can able to produce the plus R effect, and the electron withdrawing groups can able to produce the minus R effect, and the respective examples are also explained here. So, further we will discuss about few more concepts are there that we will discuss in our next class. Until that, keep note all these points whichever I have written on the board, and if you have any doubts means you can contact me. Keep watching the video. Thank you.